Good morning, everybody, and thank you for coming today. Welcome to the webinar, The Heat Pump Edge, Winning Customers in Maryland's Zero-Emission Market. Next slide. About BDC, the Building Decarbonization Coalition, with an emphasis on coalition, is a national nonprofit organization. We bring together all the stakeholders needed to make the transition to safer, healthier, and more affordable energy for buildings, advancing policy, research, transforming the market, inspiring consumers, and winning campaigns. Next slide. We are grateful to our Trailblazer members who make annual donations to support BDC's membership program. The financial support from our Trailblazer members enables BDC to keep all our webinars, policy calls, and other resources free and accessible to anyone who wants them. If you're interested in joining BDC as a member, you can visit our website to learn more and submit an application. Next slide. Some logistics for today. Everyone will be muted. During Q&A, please feel free to use the chat, and we will pose questions to the panelists. The webinar is being recorded and will be placed in our library. And for information on future calls, please sign up for our website, for our newsletter. Next slide. We have 3 panelists today: Zach from MDE, Rebecca from MEA, and Phil from LG. They will have their presentations, and at the end, we'll have discussion. So please fill the chat with questions, and we will pose them at the end. And I will turn it over to I'm next. All right, if you enjoyed today, we're also having a in-person event in partnership with GHHI on June 24th. If you would like more information, please feel free to email me, and I will be able to provide more and send you an invite when ready. Next slide.
Great. It's me. Good morning, everyone. Zach Berzolla I'm the Building Decarbonization Section Head in the Maryland Department of the Environment. If you've never heard of MDE before, our mission is to protect and restore the environment for the health and well-being of all Marylanders. We have a vision that we're going to enable healthy, vibrant, and sustainable communities and ecosystems in Maryland. And one of our key tasks, and a lot of the work that I focus on, is plans and policies to achieve net zero greenhouse gas emissions statewide by 2045. Next slide, please. If you're not aware, in addition to our climate concerns, we're thinking about air quality. And so fuel burning equipment in buildings produce over 3 times more nitrogen oxide emissions than power plants. And so this has huge health impacts. If we go to the next slide. NOx and other forms of air pollution from fuel burning equipment harms children and adults in many different ways. There are respiratory issues, wheezing and coughing, shortness of breath, asthma attacks, lung cancer, and other really significant health impacts like premature death, susceptibility to infections, metabolic disorders, preterm births, etc. These are all substantial health impacts, and Maryland is required to reduce criteria pollutants to meet increasingly stringent air quality standards and protect the public's health. And this is something we think about a lot every day. And if we go to the next slide, this is one of the reasons why Governor Moore issued executive order last summer requiring the Maryland Department of the Environment to propose the clean heat rules. And that said, to propose a zero emissions heating equipment standard regulation that will phase in zero emission standards for heating equipment to reduce carbon pollution and improve air quality inside Maryland's homes and the ambient air, and propose a clean heat standard regulation to expand Maryland's renewable portfolio standard to the thermal energy system, mobilizing investment in clean heat solutions for homes and businesses. And the ultimate goal here is to drive investment in clean heat technologies for Maryland buildings to reduce air and climate pollution. And so I want to just give you a little bit on the next slide. I'm going to talk a little bit more about those 2 policies that we're developing right now. The first is the zero emission heating equipment standard. It establishes emissions limits on residential scale space heating and water heating equipment and helps people save money. And so if we go to the next slide, ZEHES is really focused, and we call it ZEHES. It's furnaces, boilers, and water heaters. The goal here is that almost all newly installed residential scale heating equipment in Maryland would meet zero emission standards beginning in 2029. Ideally, under this program, most new air conditioning units would be heat pumps as soon as possible, because we know in Maryland that that's a really easy swap with relatively limited upfront cost changes. Furnaces and boilers would be gradually replaced with heat pumps, and combustion water heaters would be replaced with heat pump water heaters as they reach the end of their life throughout the 2030s and 2040s, right? The ZEHES rule is really about end of life replacement. People and homeowners, tenants, businesses, et cetera, can keep existing furnaces and boilers for backup heating, or running them as long as they want in their existing state. This is the ultimate goal, but we know there are some implementation challenges. We're taking feedback. I'll share our email at the end if you have feedback or thoughts on this, as we look to find a right balance between where we need to go for our air quality and climate goals, while also ensuring that we reflect the realities on the ground in this kind of a regulation. If we go to the next slide, I'll also just want to touch on our clean heat standard. The goal of the clean heat standard is to create additional incentives to help building owners transition to clean heat solutions. And on the next slide, it's really all focused on, for this audience, it's not really focused on, it's only focused on the heating fuel providers. And it's encouraging them to become clean heat providers by requiring them to help their customers adopt clean heat solutions. And they can do that in many ways. If we go to the next slide, they can help meet their goals by supporting projects like weatherization, air sealing and insulation, the installation of zero emission heating equipment like heat pumps, solar thermal, as well as the delivery of alternative fuels like biofuels and hydrogen. And for you all, the whole goal here is that contractors who provide clean heat solutions to their customers that they're already interfacing with could earn clean heat credits as well. And those are valuable to heating fuel providers. So that's creating additional incentive for the installation of these equipment, specifically, as we're talking about today, the zero emission heating equipment. And we're generally aligning with the Empower program, if you're familiar with that in Maryland. When we talk about weatherization and zero emission heating equipment, it kind of is meant to stack on top of that. And we're running a working group right now on alternative fuels and how to credit that. And so on the next and final slide, this is, if you have any comments or want to find out more, if this is the first time you're hearing about these, you can contact us at cleanheat.mde@maryland.gov, and also you can find us on the web. And looking forward to I put this picture of a heat pump in the snow up because one of the biggest feedback, one of the things we often hear is that heat pumps don't work in Maryland. And in our experience, we know that's not true, but we're really excited today to have LG talking about their experience. They're the experts with heat pumps, and as a manufacturer of a heat pump, to talk about how great they work in cold climates and places colder than Maryland. So thank you, and thanks to BDC for organizing today.
Thanks, Zach. We will pass it to Rebecca from MEA.
Hey everyone, can you hear me okay? Is that a yes? Hear me okay? Okay, awesome. Hey everyone, I'm Rebecca Price. I do go by Becky, and I'm with the Maryland Energy Administration. Thanks so much to Brian and the Building Decarbonization Coalition for inviting us. Before we hear from LG, I wanted to kind of complement Zach's remarks and provide some framing remarks on how various incentives in Maryland are helping create market demand for heat pumps. Next slide, please. just so we're on the same page, Maryland Energy Administration is Maryland's state energy office. We have a goal of advancing Maryland's clean energy and greenhouse gas reduction goals, which we do through both policy and programmatic initiatives. We're really able to chip away at our mission by dispensing funds to Maryland's households, businesses, even local governments from quite a large pot of money known as the Strategic Energy Investment Fund. We cutely refer to that as the SEEF, which is a fund where alternative compliance payments from various policies goes. And I mention this detail not because you need to memorize that, but I really want folks to know that we in Maryland do not rely on the federal government for our funding. We certainly don't complain if we get grants from them, but the show goes on at MEA as well as at our other state agencies, no matter who is in power in the White House. So like I said, we're able to dispense this money via grants, rebates, and loans through over 20 incentive programs. Those are spanning the entire clean energy ecosystem. So microgrids, offshore wind, electric vehicles, and of course, building electrification and retrofits, hopefully why we're all here today. And these programs are intended to jumpstart the market, help defray some of those upfront costs of pursuing deep retrofits and electrification. Next slide, please. Aside from the incentives that we directly administer over at MEA, I wanted to let folks know about a building decarbonization kind of outreach and education initiative that we run out of the agency. So the legislators who helped set our climate and building emissions targets in the Climate Solutions Now Act knew that the energy transition was going to be new territory for building owners and operators. So they mandated the creation of a clearinghouse of resources within the Maryland Energy Administration, known as the Maryland Clean Buildings Hub. So you can see the hub's mission statement on the screen. The hub empowers Maryland's building owners to make well-informed energy investments in their properties by connecting them to financial, educational, and technical assistance. So how does this mission statement actually manifest? We primarily serve as a convener, connector, and educator. So we're out here helping building owners understand all the funding and financing that they can leverage in Maryland, as well as technical assistance options. So in a sense, this is meant to sort of be complementary to our funding sources. We really want building owners to understand how they can leverage all of this. And then next slide. This last slide is doing what I sort of promised at the beginning of my remarks, which is highlighting some of the incentives in Maryland that are driving demand for zero and low emissions technologies, namely heat pumps. So this is hardly an exhaustive list, but really meant to remind folks that we have several incentives here in Maryland, and save for one on this list, incentives that are not tied to federal government funding. So first, again, MEA grants and loans. So I really want folks to understand that MEA is all in on building decarbonization. 2 years ago, we actually changed our fossil fuel policy at the agency such that we do not fund fossil fuel systems or equipment anymore. To give you a scale of our work, we're actually about to close out our fiscal year this month. And in this year alone, we issued a little over 200 million incentives to, again, households, businesses, and local governments. Kind of that first bullet, I obviously want to address the elephant in the room, that there's a lot of uncertainty on what's kind of happening at the federal level, but I do want folks to know that the Department of Energy has conditionally approved Maryland's applications for both of those home energy rebate programs, which were authorized in the Inflation Reduction Act back in 2022. We are still waiting on some additional approvals from DOE. That are required before we can start giving out this money. And we are actively pursuing that final approval and working with our account managers over at the department. This funding will amount to over 130 million for Maryland households. And a reminder that one of those programs provides rebates for replacing fossil fuel appliances with electric alternatives, namely, again, heat pumps. And then secondly, unfortunately, I can't go into too many details on all our incentive programs with just a few minutes, but a reminder that we have over 20 incentive programs at the agency. I'd say about half of them are focused on building decarbonization. So know that we are all in on this. second kind of main bullet, I wanted to give a nod to our sister agency, the Department of Housing and Community Development. They also provide grants and loans in the state, primarily focused on income qualified households. So this year, again, they're also closing out their fiscal year. They pushed out just under 200 million for their energy program section, which focuses on deep energy efficiency retrofits as well as electrification. So if you think about MEA and DHCD combined, we pushed out $500 million this past year on energy efficiency electrification. So we will also be working with DHCD to administer those IRA rebates. And then finally, as many folks probably know, the legislation that underpins the Empower program was changed last year. Just so we're all on the same page, Empower is a program that Maryland's investor-owned utilities are required to participate in. It was originally conceived back in 2008 as an energy efficiency and conservation program. So basically requiring utilities to provide incentives to their ratepayers for efficiency improvements in their homes and buildings. Last year, the Maryland General Assembly enacted a law that made updates to the kind of underlying legislation of Empower. And now utilities are required to add new incentives to help Marylanders make the switch from fossil fuel powered heating and appliances to efficient electric alternatives. So utilities are in the process of rolling out this new suite of incentives kind of as we speak. So we're super excited, and that really is going to be great to stack some of our MEA and DHCD incentives with Empower. Next slide. Final slide here. If you're curious to learn more about these incentives, this is how you can connect with the Maryland Clean Buildings Hub within MEA. You can email us directly. There's our email address, building.decarbonization@maryland.gov. Any question is fair game about incentives, technical assistance, kind of how to get started. And I also highly encourage folks to sign up for our monthly newsletter, which compiles information, resources related to building decarbonization. So it's kind of your one-stop shop for building decarb in Maryland. So that is it for me today. I yield back the mic.
Thank you, Rebecca, for all that really helpful information. And now we're going to move to LG. Philip, take it away.
Hey, good morning, everybody. Appreciate you guys having me here. Really couldn't have asked for a whole lot of a better segue in than from Zach and Becky. So they're the people that make the programs, that have the incentives that help you guys do business. We're the ones that provide the equipment that make it possible to transition from fossil fuels to heat pumps in a practical manner. Next slide, please. So a couple of common complaints that we hear about heat pumps. They don't work in cold climates. Heat pumps don't blow hot air. They blow this cool air that people don't find comfortable. And then heat pumps can cause high electric bills in the winter. And these are truths to some degree. But I want to kind of talk through each one of these and show you how they actually do work in the Maryland market. Next slide. All right, so I'm going to use a term called traditional heat pumps. And what I'm referring to when I say that throughout this presentation are constant speed compressor systems. And that's the systems that we've been using for many, many years. They're single stage or two stage compressors. They're limited to a speed of 60 hertz. And they're limited in the amount of heat that they're able to generate in the cold temperatures. Traditional heat pumps usually produce about a 95-degree discharge heat. And a lot of people find that to be uncomfortable, especially if they have vents that are blowing where they would walk through the airstream. They'll find it to be drafty. And so you get a lot of homeowners that push back against heat pumps, particularly if they had one 20, 30, 40 years ago when they were kind of in their infancy, and they'll just tell you, I don't want another heat pump. And as contractors, I'm sure you guys have gotten that pushback from homeowners, and it's not the same anymore. So the other problem with traditional heat pumps is the cost of the electricity that it takes to operate them in the winter. And it's not so much the heat pump, it's when the heat pump's not able to do any work anymore is when the problem comes in. So when a traditional heat pump is not able to provide enough heat for the home, it turns off the compressor and it moves over to electric resistance heat, which has about the worst COP as you can get. It takes 1 watt of electricity to make 3.41 BTUs of heat. That's just the math. That's the science. So a 3-ton worth of heat, 36,000 BTUs of heat, takes about a 10 kW heat strip, which is about 50 amps of power at 220 volts. And so when it starts getting cold, and cold is, you know, every system's a little different, but usually about 30, 35 degrees ambient is where traditional heat pumps will stop being efficient and they'll turn off and the electric heat strips come on. And that's where you see the power meter just start going into double time. And that's when the power bills start going up. Next slide. So when we're talking to homeowners and they say, I don't want a heat pump, I want a gas furnace. Why are they giving us that pushback? And I understand there's the whole movement to decarbonization and to clean air, but when a homeowner is the one that has to live with it, they may want all that stuff, but if we can't give them a comfortable system that they get to live with each and every day, when it comes down to it, they're really not going to be happy with a heat pump if it's not going to make them comfortable. So the gas furnace, it doesn't matter how cold it gets outside, that gas furnace is still going to be able to provide the amount of heat that it can provide. Where with a heat pump, the colder it gets, the less heat it's able to produce. Gas furnaces are going to provide supply air of about 120 and up, where a heat pump, like we talked about a minute ago, is only going to provide about 95 degree, that warm air that people don't always enjoy in their home. And then a gas furnace is going to use a minimal amount of electricity, especially in areas where they still have pretty affordable natural gas. They're going to look at it and go, hey, it's actually going to cost me potentially more to run this heat pump if I switch over. So why would I want to do that? Where the heat pumps, once they stop being able to provide enough heat, they transition over to heat strips, electric resistance heat that are energy hogs. So it's no wonder that a lot of homeowners are still resistant to the heat pump technology. And again, I've got tradition up there in quotes because heat pump technology has changed a lot. And the word heat pump encompasses every bit of heat pump technology, and they're not all created the same. Next slide. Hey, there it is. Not all heat pumps are created equal. So inverter compressor technology has completely changed the heat pump market. So what an inverter compressor is instead of running on alternating current at 60 hertz, which dictates the speed of about 3,400 RPM, which is what constant speed compressors, all AC compressors run at. Even your 2-stage compressors, they unload by opening a solenoid, but they still only spin at about 3,500 RPM. And that's their limit when it comes to spinning up to go get that heat in the air when it gets colder. Well, an LG inverter compressor, so it inverts the AC over to DC. And by having a DC compressor, we can change the hertz, and therefore the speed of the compressor allows us to ramp way down when we don't need to produce a lot of heating or cooling to about 10 hertz, which is about 500-600 RPM, and all the way up to about 8,000 RPM on the high end when it gets cold out. So we can spin that compressor much faster and allows us to go get that heat that's in the atmosphere when it's well below 30 degrees. Next slide. So I don't know how well you guys can see this graph. What I've graphed here, man, I wish that was clear for you. The two lines on top, the red line and the black line, are the two LG heat pumps. And these are 3-ton heat pumps. And what that is the heating output at different outdoor temperatures. And below it are 4 of the biggest brands base model. And I want to emphasize that I'm not picking on any brands, but these are just the technology, the basic single speed compressors, 2-stage compressors. If you notice, all 4 of them they track almost identical to each other because that's just what is capable of being put out by a heat pump. And essentially what you're seeing there is at 47 degrees outdoor, and these are 3-ton systems, 47 degrees outdoor, they can produce about 35,000 BTUs of heat. When you get to 17, which is around the design temp for a lot of Maryland, Maryland ranges from a design temp of 8 degrees all the way up to 20 degrees, depending where at you are in the state. But when you get to 17 degrees, if you notice, those things are only putting out about 21,000 BTUs. Well, that's not enough if you potentially not enough. And then when you get even colder, they really drop off. So one there, and what I did is I marked the highest of the 4. At 5 degrees, it's giving you 17,000 BTU. And all that data comes straight from the AHRI. Where the LG on the top, what you see is the black, that is our standard system, our inverter system. And then the red is our cold climate model. And so what you'll see is that the black and the red track very similar until you start getting to the lower temperatures. That's where the performance of the standard model really drops off. And then we get into what LG would call cold climate, which is really when you're starting to get into the negative temperatures. So for a lot of Maryland, you may or may not even need the cold climate models. I mean, I get it. It gets cold. I'm from Georgia. I grew up in Florida, so Maryland is cold to me, but really outside, when you think about the temperatures and the technology, Maryland is not a super, super cold market for us when it comes to the technology. I mean, we've got places like Maine that is the biggest adopter of heat pumps right now per capita. And, you know, places like Michigan and Canada that we're using this technology successfully. So I use this graph to show you that when somebody says a heat pump, we need to stop for a moment and clarify, what do you mean by a heat pump? Do you mean an inverter heat pump, or do you mean a traditional heat pump from the major manufacturers that you've seen, most of them being US-based manufacturers, most of the inverters being Asian companies, and a lot of that is starting to change. A lot of the US manufacturers on some of their upper end products are producing cold climate heat pumps. I'm glad to see that. But with the LG, you can see there's a significant performance difference on the heating side, on the heating output. Next slide. All right, so we've got the LG inverter heat pump, our red model, which is reliable to extreme degrees. So that's our cold climate model, which again, may or may not be needed in the Maryland. It all depends on the application. You're going to have some times where that cold climate model is the best one to go with, and other times that you don't need to spend the extra money to provide that. So LG heat pump, 100% rated capacity at 5 degrees. Traditional heat pump, like we talked about, below 30, 35 degrees, you really start to see a significant loss in capacity. Supply air temps from an inverter, LG inverter system, 125 up to 135 degrees potentially. And so what you're going to see is the colder it gets out and the more work it needs to do, the hotter the temperatures are that are going to be coming out of that register to keep the house and the home at the temperature that you desire. With the traditional heat pump, again, we talked about 95 degrees, and that's why the people aren't very comfortable with it. The LG inverter heat pump only uses resistance heat strips to supplement the compressor output. This is a huge point that I can't stress enough. So like we talked about before, with the traditional heat pump, it turns off the compressor and turns on an entire bank of heat strips that have to heat the home. With LG, what we're doing is we're using a much smaller heat strip to supplement on top of what the compressor is doing. So if the compressor is able to get you 90% of the heat that you need, we only have to turn on a little bit of heat strips to get over that hump to get the rest of the heating that we need. And that's a huge saver on the energy bill. Next slide. I put together a couple of examples of that, just real world examples. Sorry, my formatting didn't line up right there. So hopefully you guys can track with the stuff there on the bottom. So here's an example. In Maryland, I used outside temperature of 17 degrees based on a load calc. And I want to stop because every time I see the word load calc and I'm talking to contractors, I get on a little bit of a soapbox and start my little lecture. But if you're not doing load calcs, if you're not doing manual J load calcs, it is impossible to be successful with heat pumps. It's impossible. There's no way to know how to size it. If you're using 400, 500 square foot per ton, There's no way to know if you're going to get enough heat. You're going to oversize or you're going to undersize, and you're going to be in trouble either way. So you have to do a load calc. There is great software out there on the market. I've been a contractor. I've done a load calc at every single home that I've been at. So no excuses. Go get the software, take the time, be better than everybody else, and do your load calcs the right way. Okay. So this house requires 38,000 BTUs of heat based on our manual J load calculation. And we're going to install a 3-ton heat pump. So if we were to use a traditional heat pump, we're going to have at 17 degrees, when it starts getting cold out, when we get to that design temp, we're going to get nothing out of the compressor, right? Because it's already turned off because it can't keep up anymore. It's going to need 12.5 kW heat strips. Well, it needs 11.1. So we're going to install a 12.5 because that's the next size up. And what that is that's going to have a 62 amp draw. You're going to have 52 amps coming from the heat strip, or sorry, 57 coming from the heat strips, and about 5 amps for the fan motor to blow, versus an LG red system. So this is a cold climate in this example. We're still able to get 39,000 BTUs of heat from the compressor at 17 degrees outside. So we've got enough heat to meet the requirement of that home, which means I don't need anything to come on from the heat strips. So at 17 degrees, I'm going to be drawing 18 amps on the LG system versus 62 on a traditional heat pump. That is why you can efficiently use a heat pump and not kill people on their power bills in the winter. All right, next slide. There we go. So let's look at a home with heat strips that we're going to use some heat strips. And there's a time and a place to do that. So in this example, outside temperature, 17 degrees again. This home requires 44,000 BTUs of heat at 17 degrees. Again, we wanted to use a 3-ton heat pump. Why 3-ton and not 4-ton? Because maybe the 4-ton would be much too large in the summer. You know, we have manual S requirements that don't allow us to oversize on the cooling side, which is a mistake that a lot of contractors make. They're like, well, I'll just design for my heating and throw manual S out the window. And next thing you know, they're 50, 60% oversized on their cooling. And that's not good either. So if we have this scenario right here at 17 degrees, again, with that traditional heat pump, you're going to get nothing out of the compressor. It's done. It's turned off. It said, hey, I can't keep up anymore. We need the backup team. So they're going to go to the backup or the emergency, whatever you want to call those heat strips that are installed there. You need 12.9 kWs to put out 44,000 BTUs of heat. So that's a 15 kW strip. That plus the fan motor is going to give you 73 amps of power requirement to heat that home. With an LG system at 17 degrees, and this is our standard system. I didn't use the cold climate one in this example. In this one at 17 degrees, you're going to get 37,000 BTUs out of the compressor. We need I think that's supposed to be 2.3 kW needed. So we're going to add a 3 kW heat strip. Look at that, a 3 kW instead of a 15 kW heat strip. 3 kW. So when that heat strip plus the compressor plus the fan is running in the coldest part of the night, we're going to draw 36 amps instead of 73 amps. So even when we're using heat strips, there's a massive amount of savings. And again, those strips are only going to come on where that house needs more than 37,000 BTUs. So not only is the heat strip draw much lower, the amount of time, the amount of hours per year that those heat strips are actually going to be activated, tremendously less than with a traditional heat pump. Next slide. Right. So like we talked about, inverter compressor technology completely revolutionized the modern heat pump. When you go to your supplier, you go to your distributor and you say, hey, I need a heat pump. There's lots of different choices. There's still what I would call traditional heat pumps that are out there. They're still being incentivized to some degree. And I think we need to do a lot of work to define what heat pumps we want to offer. And I think a lot of that needs to be at the performance of those colder climates to make sure that we're not We're not throwing in a heat pump that we have to back up with a large bank of electrical strips, because that doesn't really get us to where we want to be. And it's not the technology that really is going to move us forward in the market. So there's a lot of confusion out there, both for homeowners and for contractors, when you say heat pump, because some heat pumps are fantastic and some heat pumps, frankly, aren't. And both are available. So we need to have that deeper conversation of, what do you mean by a heat pump? What are you defining as a heat pump? There are criteria for what defines a cold climate heat pump. As you can see, I showed you both of LG's. I showed you our standard and I showed you our cold climate. Both of them are still very different than the traditional single speed compressor heat pumps that we get from lots and lots of other manufacturers. So just have that conversation, have that awareness, understand that there is a difference. So when you hear the phrase heat pump, pause for a second and make sure that we're talking about the same type of heat pump. So HRI rated capacity, when you see that the rated capacity for a heat pump, that's at 47 degrees outdoor temperature. Well, that's all well and good, but that's not real life. That doesn't really help us out when your design temp in Maryland is 10, 12, 17, 20 degrees. I don't really care what it can do at 47. I need to know what it can do at colder temperatures. The good news is that HRI also has an output listed. It's not the rated output, but they do have it listed when you pull up the system at 17 degrees. So that's the data that I used in that chart. You can go to the system that you're looking at and go, okay, that's all well and good at 47. What can you really do at 17? And if you look at it at 17 and it has a tremendous drop off in output and capacity, it may or may not be the system that you want to offer to your homeowner. Next slide. Right. So from a contractor standpoint, I get a lot of pushback sometimes, and some of it is fear of the unknown, fear of the change. It's different. The inverter systems, they look funny, right? They don't blow out the top. They look like a suitcase and they blow out the side, and they got all these computer boards in them, and I'm a little bit scared of them. And I get that. Right. But the change is not as big as you think it is, right? The refrigeration cycle has not changed, just how we look at it. Can we go back one slide real quick? Right. So what has changed in it is that we're no longer using mechanical devices to control the refrigerant flow, right? So in a traditional air conditioner heat pump, we've got a compressor that's constantly spinning, and it pushes the refrigerant, and then it goes to a TXV, and that opens and closes based on the coil temperature, and that lets the refrigerant into the coil as it needs. And we've moved from doing that to an electronic version of that. So now we've got sensors and computers that are actually monitoring temperatures at different points throughout the system, and it's using an electronic expansion valve along with a variable speed compressor to send the amount of refrigerant, exactly the amount of refrigerant that we need to the indoor coil to create the temperature that we need. So we're not using gauges any longer to hook up to these types of equipment. If you are, please stop, because when that compressor is not running at 60 hertz, you have no idea what the pressure should be. And so all we're doing is creating disruption. We're removing refrigerant from the system, contaminating it with the wrong kind of oil, because we don't use POE oil. So quit using your gauges on inverter heat pumps. What you're going to use is you're going to use a computer or a phone, and it's going to give you all the information that you need. And I get it. That's scary. And if you talk to any mechanic that was in business about 30 years ago in the 90s, they went through the exact same thing. They used to use vacuum gauges and timing lights to tune cars up, right? To set the carburetors, which was a mechanical way of metering the fuel and air that went into the engine. The engine didn't change. The internal combustion engine didn't change. It still takes air, fuel, compression, and spark to make the engine run. Well, the refrigeration cycle is the same. It still takes compression of the refrigerant, expansion of the refrigerant. It's just how we meter it and how we control it is just like what happened in the cars in the 90s when they went to fuel injection. So now you go to a shop, they plug a little computer or scan tool into the car, and it tells them everything that's going on in that engine. They're not using mechanical vacuum gauges and that kind of stuff anymore. So we're doing the exact same thing. The HVAC industry just took about 30 years longer to finally get to this point, but that's what's going on. So it is a change, and there is some education required, but we can help with that. Next slide. So yeah, just to drive the point home, the old way, mechanical gauges, whether they're digital, whether they're analog, doesn't matter. They're still just looking at the pressures of the high side and the low side. The new way, you're going to plug up something like that dongle right there, and it's either going to go to your laptop, your phone, your iPad, and it's going to give you the pressures of the system. It's going to give you coil temperatures. It's going to give you the speed of your compressor. It's going to give you how open or closed your expansion valve is, and lots and lots and lots of data. You can even watch the data and record runtime sessions and things like that. So it's just how we look at the data is different. You know, the skill set that we have as contractors hasn't changed. We still need to understand how a system works. It's just we look at it in a different way. So everybody's like, okay, I want to learn more. Next slide, please. So we have training academies, and every manufacturer does. Obviously here I'm with LG. I love LG. In my opinion, we make the absolute best products in the world, but I understand every manufacturer out there has their training. But if you're interested in some LG training, which hopefully you are, we have 6 training academies, or soon to be 6 training academies throughout the country. And I know most of this audience is from the Maryland area. So I listed our LG academies, which the closest one to you, I think, is New Jersey. So if you guys want to take a trip up there and see our amazing facility that we have, it's actually a beautiful building we just built right on the river, right outside of New York City. It's awesome. But we also have some partner academies with our local distribution company. So Thomas Somerville is our distributor in the area. They have 2 academies. They are the same training that you'll get from LG. So if you want to come to LG, great. If you want to go see Thomas Somerville, fantastic. You're going to go through the exact same program. Their trainers have been to the LG training. They've been certified by LG. So they have one location in Chantilly, Virginia. Another one, I believe it's coming very soon in Seaford, Delaware. So those are going to be some local opportunities. And obviously Thomas Somerville, if you're looking for equipment, I'd love to get you connected with those guys over there. Great people, but they can help you with the training, the support, anything that you need, warranty parts, and obviously new equipment for new jobs. Is going to go through Thomas Somerville locally for the Maryland people. Next slide. So one little pivot, just want to throw this out there, and I don't have time to really dive into the heat pump water heater. I just want to show you that LG makes an inverter heat pump water heater. It is the most efficient tanked water heater on the market. It's the quietest, comes with a 10-year warranty. It's a fantastic unit, guys. I put it in my house a little while ago. Absolutely love it. So there's a lot of programs, a lot of decarbonization going on. And water heaters are another big piece of that. So I just wanted to throw that out there that we also have the inverter heat pump water heater available for you. So I think that might be my last slide. Next. Oh, so a little bit about the water heater. I did put a little information in there. Sorry. So it's going to require a 30 amp service, just like what you're using on a typical electric water heater. The differences are it connects the water on the side. You can sort of see it in that picture. You can see the water connections there. And then the only other difference is you need to add a condensate drain because it's a tanked water heater with a heat pump sitting on top of it. So it does produce condensate. But other than that, the installation, if you can put in an electric water heater or if you're doing a change out for a customer, super, super easy. No big deal to put this in. It doesn't require a lot of extra skill. So pretty easy there. Next. All right. That formatting didn't work either, but there's our website. So if you want more information, it's lghvac.com. You can look up training. You can look up product information, all that kind of stuff. I did not put my contact information on a slide, so I'm going to go to the chat as soon as I'm done here. I'll put my name and email if you guys have any questions that you don't get to ask during this time. I want to make sure that we follow up. And if you have anything that you want to contact me about, I'm more than happy to work with each and every one of you guys. So, hey, Andy, I just saw you pop up on the chat. How you doing, buddy? Yeah, so I think we're ready for questions for myself and Zach and Becky. So guys, thanks. I appreciate it.
Thanks, Phil. Really good, really informative. Learned a lot. We're going to start with our questions. Our first is from Daniel. If we have a heat pump with a DOE rated capacity of 32,000 BTU at 17 degrees Fahrenheit and a maximum capacity of 39,000 BTU at 17 degrees Fahrenheit, what can we promise customers?
Can you read that again? Because those numbers didn't track in my head. I'm sorry.
Hang on, being edited. Put it in the chat.
All right, let me pull the chat up. Sorry. DOE rated at 17 and a maximum capacity at 39. What can we promise customers? Okay, so that's a great question. That is a great question. So when you look at an inverter heat pump, an LG, other brands are the same way, you'll have two output tables that are available. You'll have rated capacity and you'll have maximum capacity. Rated capacity, when they do the AHRI testing, it's actually a part load capacity for an inverter system. We ramp that compressor down and we lock it at a certain speed, which is where we're going to get all of our certification numbers at. There's a little bit of a game that gets played there because we can get a little more output, but we may lose on the SEER or the HSPF or COP numbers. But 32 is that rated capacity doesn't really matter. It's not a real life number. It's a locked in part load capacity that they use to get efficiency ratings. But if it has a max capacity of 39,000 BTUs, you can get 39,000 BTUs out of it.
Awesome. Thank you. Go to our next question. Is there an advantage to keeping a gas furnace connected and running it during very cold periods? Or do the LG inverters beat the efficiency of gas furnaces in all temperatures?
That's going to depend on every situation. So what is the gas rate? What is the electric rate? And what do you define as cold? So if we're in Minnesota and we're going negative 15 degrees or whatever, negative 10 degrees, yeah, there's probably a time where efficiency is going to be better out of a gas furnace, especially if you have like a 95, 98% furnace running on natural gas. If you have an 80% furnace running on propane, I mean, the heat pump's going to blow it away. So it's really hard to just answer that in a blanket statement. So each and every scenario is going to be different. In the Maryland market, I would say there might be a few moments out of the year where a high efficiency furnace would be, quote, more efficient. But I don't think you have enough of those cold hours a year to really make the argument that you need to have a dual fuel system. It's not a bad thing other than, we're trying to decarbonize and go all electric. But when you look at it from a homeowner standpoint, I don't think it's a bad thing, but I don't think it's really a necessary thing for you. I mean, we make a coil that works with a gas furnace, but the primary focus is really on the electrification possibilities.
Go to our next question. Can you please help? Can you share what incentives or rebates are available for folks making the switch from oil to electric?
That one's for me, the $1 million question, literally. So I just want to caveat my remarks in that incentives are not a one size fits all kind of panacea. We need to know a bit more about who your building type. I'm assuming it's a single family home, just given the context of the webinar, your utility income. But I'll just sort of say generally, I'm going to speak as though you are a single family home. Like I said, the investor-owned utilities. So, think the big ones: BG&E, Potomac Edison, Pepco, Delmarva, are revamping their incentives. Like I said, providing electrification incentives. I know BG&E is on the top of my head. So they're HVAC residential. They have like a Make Ready, I think is the name of their program. It includes they'll fund 75 up to 75% of cost of an electrification swap up to 3K. That does include panel upgrades and wiring. They also have appliance rebates for heat pump water heaters. I was super glad when Philip talked about his. That rebate is, I think, up to $2,000 right now. I think I saw Chloe from BG&E in the chat if she wants to chime in and confirm those numbers. So TLDR, I would really start with your electric utility. I can sort of talk briefly about the IRA rebates, although again, the major caveat is that we do not have those in our coffers yet. We are still waiting on final approval from DOE. I'm just going to go ahead and sort of paste in the chat our 3 pathways. I think all of them are sort of income eligible pathways, but you'll see, just give me a moment. Ooh. Might be too big to paste in the chat. But like I said, we're going to be giving some rebates to our sister agency over at the Department of Housing and Community Development. Those are reserved for low-income households, so defined as 80% of area median income. We also have a fuel, oil, and propane conversions to electric heat pumps pathway. And that will be for low and moderate income households. So that's 80% to 150% AMI. And then finally, I will paste in the chat our incentive page on Maryland Energy Administration's website. You'll see there's sort of a menu there based on building type. So you'll see the commercial incentives, manufacturing, single family, multifamily, etc. So just give me a moment. I'll paste that in. Hopefully it'll actually paste. And then finally, I just want to reiterate that email address, building.decarbonization@maryland.gov. If you email us, give us a bit more context, we can kind of help you through that.
Thanks, Rebecca. And we will also send a follow-up email with all the important emails and links as well from the chat that you all shared. We will move to our next question. All right. Look, Phyllis, for you, I'm going to paste this in the chat as well, as it is longer. Bill, yeah.
What's that?
Is
there another one?
Yeah, I put a question in the chat for you.
Oh, I'm sorry.
Yeah, no problem.
I've heard that some homes in the Northeast install heat pumps have higher energy costs, even more than when they had gas furnaces. True statement. Can you describe the typical home that will see overall reduction in energy costs? What variables need to be true for the cost savings for a homeowner? I hope that I've addressed that already. I think that question came in pretty early in the presentation. So if you have that still, please reach out to me. I put my name and number in there. We've got 4 minutes before we have a hard stop. So if you don't mind, I'm going to jump to a couple of other questions here.
Feel free.
We talked about that. Do you recommend surge protectors on an all inverter equipment? LG is neutral on that. We're not going to tell you have to, but I can tell you from my experience, surge protectors are not enough. Absolutely recommend them, but what I recommend is a voltage monitor protection system. And because that is going to protect all of your electronics against both surges, high voltage, but also low voltage. Low voltage is the one that gets overlooked all the time. And when we have those dips in the voltage, that creates extra heat in the electronics, and that's going to cause detriment to your system. So there's several companies out there. Diversitech has something called the CoolGuard 2. RectorSeal has theirs. ICM 493. There's some great ones out there. But again, LG doesn't endorse any of those. We're neutral on them, but those are just some to look at. What do you say if and when a homeowner brings up concerns about switching to a heat pump in case of a winter electricity blackout? I love that question because I want to know what's going to run the fan in their furnace when the power goes out. They don't have any electricity. They can't run their furnace even when the power goes out. So either way, they're going to be stuck without heat when the power goes out, unless they have a backup generator, which is why you want an inverter heat pump instead of an on-off heat pump. So you're going to look at the lock rotor amps when you're doing a generator and you're figuring out how much can it operate. It's not so much how much can it operate, it's how much can it start up? How much amperage does it take to start that compressor and those motors? When you look at a traditional heat pump, it can be 60, 80, 90 amps just to start the outdoor unit, plus the amperage from the indoor fan coming on at the same time. It takes a lot of power for that generator to run it. LG has a soft start, very, very, very low lock rotor amps. So for instance, my home, I have 3 LG systems. I have a little mini split in the basement, 2 full-size ducted systems. I run my entire house on a 9 kW Harbor Freight generator that I plug right in, that I've wired into the panel. And I run all of that plus my heat pump water heater on a small, relatively small standby generator. So that's what I would say to that. Did I miss anything, Brian? Have you seen anything pop in that
I think you covered it all. So I think we're going to start wrapping up.
cool?
I think
I put my contact in there, guys. Please don't hesitate to contact me or Mark or any of our team at LG. We want to be a resource for you guys. Brian, thank you for having us. Zach, Becky, you guys are awesome. Thanks for everything that you do. We appreciate it.
Yeah, thank you all. I want to thank our panelists for being here today. I want to thank you all for joining, learn a little more about heat pumps and all the things happening in Maryland. We will send a follow-up email with all of the important links and a recording. So hope you all have a great week and thank you for your time today.